We are going to start with 10th IGCSE Computer Science syllabus, and the first chapter we are going to discuss is data transmission. It has three main parts. First is methods and type of data transmission, methods of error detection, and encryption. Today we will read about how the data is broken up into data packets, what is the structure of this data packet, and what is packet switching. So first three topics we will see today. Let's start. So firstly, we will discuss what do we mean by a data packet. So whenever you transfer a data over a longer distance, it is very difficult. For example, you are transferring nearly 10 GB data or maybe 1 GB data to a computer over a long distance. So that's very difficult. So what we do is we break down this data into data packets so that it can be easily transferred. And size of one data packet is nearly 64 KB. Every data packet is nearly 64 KB. This 64 KB is usually small, so it is very easier to control rather than a long data packet. So this data that we split into pieces or we broke down into pieces, so these pieces are known as data packets or datagrams. So data sent over longer distances is usually broken up into data packets, and the size of this data packet is nearly 64 KB. And every packet that you break down, it is taken into a different route, a different path, so that they can easily reach the destination. It is of a great benefit because now the data will be transferred easily and in much faster manner. But once you reach the destination, you have to reassemble them. Why? Because all are broken down into pieces and they are sent among different paths so they can reach different destinations. So we need to reassemble them once they reach the destination. Okay, now let's discuss what is the structure of this data packet that is broken. So when you have to send the data in long distance, you break it into data packets. Now we will discuss what is the structure of the data packet. So data packet is split up into three parts. One is the packet header, next is the payload, and the last one is the trailer part. So in header part, we have four further divisions. In header, we have the IP address of the source device. That means the IP address of the sender is present. So whenever a data is sent, we have a sender. So sender is a computer that is sending the data, and then we have a receiver. So receiver is the device that is going to receive the data. The data is always traveling in the binary format. Let's say this is the data that I'm sending. So this data which I am sending will be delivered in a packet. That means a data packet. Data packet is divided into three parts: header, payload, and trailer. And the header has IP address of the source, which is sender. So what does IP address means? So IP address is nothing but the address that uniquely identifies a computer. So IP address is nothing but an address that uniquely identifies a computer. So like we all, whenever we write a letter up to a post office, we write the address of our own house. So it's like the address of the computer. Also it contains IP address of destination. Why? These two are required so that we know, at every point we know who is the sender, from where the data has been sent, and from where the data is getting received. And the sequence number of packet is also available in header so that the packet can be correctly reassembled. So for example, as I gave you example that let's say there is a data of 100 MB, right? The big data of 100 MB, and it is broken down into data packets, into 10 data packets, right? Now let's say while traveling, some reach first and some reaches next, right? So they can get scrambled up, their positions can change. So what we have to do is, while we break them down, we can give them sequence number, that this is the first one, this has to be the second, third, fourth, fifth, sixth, seventh, and eighth. So that whenever we combine them again, they are combined in a correct format and not like random format. So that is why we will be using the sequence number of packet. Next is size of packets in bytes. So when we divide it into packets, usually we divide it into 64 KB. But if there is any other size division, that also we can mention in the size of packet, that how much bytes the size that packet is taking, right? And then we have payload. So payload is nothing but the actual data in packets. So like here I told you that 101011 is, let's say, the data that I am sending, and it will be sent in a packet. So this is the actual data that I want to send. That will be stored inside the payload. So payload is nothing but the actual data that you are sending, that is inside the payload. And then we have the trailer part. So trailer contains the method of identifying the end of packet. So trailer signifies the end of data packet, that this data packet is ending at this point, and also it has the error checking methods. So two things, it identifies the end of the data packet, that data packet is going to end here, and also it contains some form of error checking methods. Let's see next. So as discussed, each packet header consists of IP address of sending device, IP address of receiving device, sequence number of the packet, and packet size means the size of the packet, right? How much bytes it has, and payload, as we discussed, it contains the actual data that you are sending. And similarly in packet trailer, we discussed that it contains the way to identify end of the packet, that the packet is going to end at this particular point, and it also has some error checking method, for example cyclic redundancy check, CRC. So in packet trailer we have an error checking method that is also known as CRC or cyclic redundancy check. See, in 4 steps they have mentioned what is cyclic redundancy check doing. So first of all, what happens in cyclic redundancy check is add up all the 1 bits in payload and store it in hex value that will be sent in the trailer part, because trailer part contains the error checking method. So I will give you one example. For example, we have a data packet. Let's say there is some header H, trailer T, and original data is inside the payload. Let's say the data that I am sending is this. Okay. Now I have to add up all the 1 bits in the payload and store it as hex value. So my payload is 101101. So add up all the 1 bits. How many 1 bits do I have? 1 plus 1 plus 1 plus 1. 1, 2, 3, 4. So 4 1 bits I have. Now I have to store 4 in hex value, as we know that hex value is nothing but 0 to 9 and then A to E, right? A to F. So 4 is written as 4 only in hex value, and that will be sent in trailer. Okay. So hex value will be stored as 4. Once the packet arrives the receiving computer. Okay. So let's say this is my sender, and then I have a receiving computer. To the receiving computer also the packet will be delivered. So we are sending this packet only H and T with original information as this. The computer checks this value against the value sent in the trailer. So as I told you that in this trailer part only this 4 value, which is the hex value, will be sent. Why? To check if error is there or not. So what receiver will do is again recalculate the hex value. So add up all the ones here, 1, 2, 3, 4. So again all the ones add up to 4, right? So that means the hex value is 4 only, right? So it will check this recalculated value with the sent value. So one value will be sent in the trailer. No? So both are same. When both are same, that means there is no error. So I hope you have understood cyclic redundancy check. If you face any issue, you could rewatch this video from this point, or if you face any issue, you could write in comment section. I'll explain again. Okay. So now we will understand what does packet switching mean. Packet switching means that when a data is sent from, let's say, A computer to B computer, and now the data is broken down into a lot of packets, different packets. So what packet switching says is that these packets could be sent to different paths and they can then reach the computer B. Let's see how it happens. See this. This is computer A, and so different routers are giving us different paths, right? And all these R1, R2, R3, R4, R7, R9, all these are different paths. So what they're saying is the different packets can go through different path and then reach router B to computer B. So root all R1 to R10 are nothing but routers or nodes in a network. So a router, what does a router do? Router receives a data packet, and based on the information that is present in the header part. So what is present in the header part? IP address of sender, receiver, right? Sequence number and size of data packet. So based on that information, it sends the data to the next node or the router. So here is the example. If you see here, there are, let's say there is a data that was here and it is converted to 5 data packets of different colors. It is shown here, and let's track the red one. So red data packet goes from here to here, then here, then here. So this is the path which is followed by the red data packet, right? And if you see, let's look at the green one. The green data packet followed this particular path. So the data packets can follow different path. Whichever path is free, they will follow and reach the destination from that path. This process is known as packet switching. So packet switching is nothing but a transmission in which a data is broken into small packets, which is data packet, and each packet is sent independently from start to end point. Like from, let's say this is the start point, computer A, and computer B is the end point. So from the start point to the end point, all the information, all the nodes we have R1 to R10, different paths. So each packet is sent independently along the different route. That's what packet switching means. Packet switching is nothing but a method in which data is broken into data packets, and these data packets are then sent along different routes from the start to end. And what is the benefit? Benefit is that we don't need a single communication line. Why? Because if there is only one communication line between A and B, let's say this line is busy or faulty, sometimes there is some problem in this particular wire, then we won't be able to transfer the data. And it is easy to send a large amount of data when you break it into packets. Also, the speed of data transmission and high data transmission rate is possible. And what all are the drawbacks? Drawbacks is that when you're sending them from different routes, there could be a possibility that packet is lost and you need to resend the packet. So that's one drawback. And other drawback is real-time streaming. Okay, so real-time streaming, that means, for example, you are live on YouTube or you are conducting some Google Meet. So that is, in that case, there could be errors because they are following different paths. So this could be possible that the packets are not arranged in the correct format, and there could be delay. Why delay? Because once the packets reach the destination, that means at this point they needs to be reordered because they are following different paths, they have their different speeds, and let's say a brown packet or green packet reaches first. So what it can create a problem. So what we have to do is we have to give them a sequence that yes, this is my packet 1, this is 2, this is 3, 4 and 5, and it has to be reached in the same way 1, 2, 3, 4, 5. So that's what we have to consider. So they need to be reassembled and reordered at the end. That's what makes it a drawback. Okay, thank you for this session and see ya in the next session. Like, share and subscribe the channel.